Hello everyone. I am Priya from CSC Department of Hindustan College of Engineering and Technology. Today I am going to take the topic of CPU scheduling from operating systems. The basic things we are going to discuss under this presentation are various CPU scheduling algorithms, scheduling criteria, and real-time scheduling algorithms, and what are the simulations we are going to discuss. So the basic concepts here: maximum CPU utilization by using multiprogramming, CPU and IO burst. So usually CPU burst followed the IO burst, and this is the diagrammatic explanation of CPU burst and IO burst. So when the process is executing in CPU, if it requires any IO request, then the particular process goes for wait state, and after the completion again it will get the CPU and continue the process execution. So the specification here is CPU burst and IO burst. So under the execution it is mentioned by CPU burst. When it is using the IO, it is mentioned by IO burst. Then CPU scheduler. CPU scheduler is the short-term scheduler. Always select the particular process for the CPU to execute a particular process. We have two types of scheduling, preemptive and non-preemptive. Actually, if the CPU is allocated for the particular process, the CPU executing the process till the end of its completion. This kind of scheduling is called as non-preemptive. That is, till the end of execution, the particular process won't releases the CPU. So this is called as non-preemptive. If the process releases the CPU due to some IO or external request, that is called as preemptive. Then these are all the various scheduling criteria we are following: CPU utilization, throughput, turnaround time, waiting time, and response time. So CPU utilization is nothing but as long as the CPU should be maintained busy. Then throughput, maximum number of output received. Then turnaround time, so the amount of time which is used to execute a particular process. Then waiting time, the amount of time spent in the waiting, that is in ready queue the process is waiting. Then response time, the submission of the process and the first response received, that is called as response time. So we have four types of scheduling algorithms here: FCFS, SJF, priority, and round robin. First one is FCFS, that is first come first served. So from the name itself we understood the first entered process will get the CPU first. This is called as FCFS algorithm. So here consider we have a sequence of process, then burst time. So process P1, P2, P3, and the burst time 24, 3, 3. So this is the chart we are using, Gantt chart. So in this Gantt chart, the first process P1 entered and the total execution time, that is burst time, is 24. So the waiting time of P2 is the execution time of P1. So 24 milliseconds it has to be wait for the receiving of CPU. Then for P3 the total waiting time is the burst time of P1 and P2, so 27. So that average waiting time is calculated by the waiting time of P1, P2 and P3. So which is divided by the number of process. So 24 plus 27 plus 0 divided by 3, which is equal to 17 ms. Then the next one is shortest job first. So here the shortest job will be allocated to the CPU first. So these are all the sample process and burst time P1, P2, P3, P4. Here the last process P4 is having the minimum burst time, so it is allocated to the CPU first. The next one is P1, then P3, at last P2. So in the order of the shortest job, the total waiting time and the average waiting time will be calculated. Then round robin. So here it is using the shortest time duration, which is called as time quantum or time slice. So usually it is varied from 10 to 100 milliseconds. So it is FCFS, same as FCFS except the time slice. That is, periodically the process will get the CPU for the duration of time quantum. Say for example, if the time quantum is 4 here, then for each and every 4 milliseconds the sequence of processes will share the CPU. Say for example, process P1 is having the burst time of 24, P2 3 and P3 3. So our quantum time is 4. So 4 milliseconds each and every process will share the CPU. So first process P1 will use the CPU for the first 4 milliseconds. Then the process P2 will use the CPU, but it required burst time is 3 only. So after the completion of 3 seconds it will release the CPU. Then P3. After completing the P3, again the CPU will be utilized by P1 process till the end of total burst time completion. So the average waiting time will be calculated by waiting time of P1 will be the P2 and P3 burst times total. So this will be calculated like this. The next one is priority scheduling. So here we are adding one more value along with the process and burst time specification, priority. So this priority will be added to the specification of process. So based on the priority number, the process will be allocated to the CPU. So that is the only difference. So compared to all the things, SJF is a better algorithm compared to remaining algorithm. Thank you.